करना मोहित, वो
हाँ मैं
फालतू।
भी कह रहा हूँ यार, मतलब
हाँ हाँ ठीक है, वो टेलीग्राम वाले पे
वो
मत करना।
ठीक है।
हम्म।
ओके।
ये सो कौन देना चाहेगा पहले?
चलो मैं ही दे देता हूँ।
ओके ओके सन। So Pawan, you start from your side.
Okay. Sanu, tell me what is the supercritical, critical, and subcritical reflection?
Supercritical and critical
Supercritical,
and
subcritical reflection. What are the basic difference?
actually I only know the critical one. So critical one, it is the means where the we got the critically refracted ray fast than the direct ray. So at the point there is a critical reflection happen. So that ray is the called critical ray, and supercritical I don't know.
Okay, okay. No, in gravity method we measure gravity variation. Why we are not measure gravitational force? Any
Because
reason?
gravitation force, it's depend on the mass of the means it will not that much efficient. We are measuring
Gravity depend on mass.
gravitation. Can
Gravity
you
also.
repeat? Can you repeat your question?
I'm asking that in gravity method we measure gravity variation. Why we are not measure gravitational force?
We are measuring actually gravitational acceleration.
Yeah, yeah.
So force, if we multiply with the mass, then we can get easily the force. So actually, acceleration is the basic thing, fundamental thing, and the force we can get it by multiplying the mass of this instrument or any we are using.
Okay, okay. Can you divide category of earthquake which depend on the region where it occur? Category of
It's
earthquake depend on the
okay.
region where it occur.
So it is mainly in reason we are means when you are basically asking the interpret and interpolate earthquake,
No,
na?
no. I'm asking
So
that depends on the region where it occur.
means it is between plate boundary.
Yeah, yeah. Tell me.
So the natural earthquake are mainly it is found in the plate boundary. So when the two plate are where there is convergent or divergent or transboundary movement. So that's why the plate. So the collision between the two plates. So earthquake is generated.
Okay, okay. Do you know density range for granite material?
No, sorry, I don't know.
Do you know some hidden layer we obtain in a seismic refraction? What is the meaning of hidden layer?
Yes, the hidden layer means that we can't get the layer because the if there is a velocity contrast in between layer. So suppose the upper layer is velocity is higher than the middle layer. So that layer we can't get that layer. So we were assuming we are means we are get travel time delay, but we can't miss that because there is velocity contrast, and so that layer we can't detect it. That's why it's called hidden layer.
How to overcome this problem? How to overcome this problem? Hidden problem. Any method?
I think we using the filter or convolution. I'm not sure about it. Just
Mm, okay, Sanu, I am done.
Arpita.
Yes, Sanu, can you tell me the principle of seismometer?
Principle of seismometer.
Yes.
So seismometer is basically using the properties of inertia. So when the ground is motion, so its property of inertia to stay in rest, and when it's moving, it will remain move. So that property we are using to detecting the earthquake or any ground vibration. And so
Is there any law in physics that defines the inertia?
Newton first law is the defining the properties of inertia.
Okay, what is the Newton's first law?
So Newton first law tells that that every body which is staying in rest, it will remain in rest, or every body which is moving, it will remain in moving until if we are applying any force.
Okay, tell me the types of seismometer on the basis of time period.
So there is a two type. One is long period and the short period of seismometer.
Okay, and other names for the long period and the short period seismometer?
So long period is the called displacement meter, and short period is accelerometer.
Can you tell me why long period seismometer is known as displacement meter?
So actually, its amplitude is proportional to the displacement, and the short period its amplitude is proportional to the acceleration.
Okay, have you heard about the broadband seismometer?
Yes, yes.
Why do we need it?
So actually, in short period or long period, we are so short period it is measured. I think that 0.1 to 1 second, and the long period it is the measure greater than 10 seconds. So in between we can't measure it. So broadband seismometer we are using because that we can measure the all the ranges. So it will
You are telling 0.1 to 10 and greater than 10.
no short period. I think 0.1 to 1 second. I think
Okay, and for long period it is?
it is. I think long period it is greater than 10. I forget that number.
Okay, so why do we need the broadband seismometer?
So basically, we are measuring that the small oscillation, which are sometimes it is creating noise due to man-made interaction or all these things. So sometimes we can't detect the small signal. So detecting for the small signal, we are using the broadband.
Okay, thank you. I'm done.
Okay, Gauri.
Sanu, what is the principle of gravimeter?
So gravimeter, it is the it works on the Hooke's law. So so when we are applying the force, so it's change the its length, means we are using this spin coil. So restoring force is the proportional to the change in length. So we are using the concept, and
Okay. Okay, so what are the different types of gravimeter?
so there is a two types of, one is the absolute gravimeter and another is the relative. So absolute gravimeter we are measuring the absolute value of the gravitation acceleration, and the relative one we are measuring the just change, just the difference.
Have you heard of unstable gravimeter?
Unstable, stable, and unstable one. And so, unstable one, we are actually measuring the relative gravity.
Okay, why we are using Nowadays we are using unstable gravimeter mostly. Why
So
we are
unstable gravimeter, it is means its accuracy is much better than the stable one.
I
And
didn't
so
get the point. Can you repeat it?
what
I didn't get
can
your
I?
answer. Do
So
you repeat it? Can you repeat it?
yes, repeat it. No, I am not on. What are you are saying that absolute gravimeter?
Why we are
Why we
using
are using the
unstable
absolute
gravimeter
gravimeter?
nowadays? Unstable.
Okay. So unstable we are using that for the better accuracy. So better we can. So unstable can measure. Uh, I think 0.01 milligal its accuracy.
You mean the
So
sensitivity?
sensitivity is higher than the other gravimeter
Okay,
we are using.
okay. So what is zero length spring?
Zero length spring. Okay. So zero length spring is the concept introduced in the latest Lombard gravimeter. So here that we are using the principle of that. If there is no force, so natural length of the spring is zero. So when
Okay.
there is no force and that's why it is called the zero length. So there is, if there is no force, there will be no spring. So natural length of the spring will be zero, and it will achieve by the means we are using the helical shape spring, and we give the extra twist on this that so it will tendency to uncurl the spring.
And what is the significance of zero length spring?
What is the significance of
Zero length
zero
spring.
length spring?
Why do we
Oh,
use that? Why do
so
we implement it?
we are using basically because its zero length spring is higher accuracy, I mean higher sensitivity.
Okay, that's all.
Mohit,
Yeah. Hello, Sanu.
Yes.
Can you tell me what are the different corrections we use in the gravity survey in the systematic order, like what we do first and then second and third?
Okay. First we did the drift correction. So drift is the instrumental correct means we are as change in the instrumental length or all these things due to temperature and other effects. So we'll first correct that. Then the latitude correction. So latitude as we are moving from the equator to the pole. So there is a because due to the Earth rotation, so centrifugal force will be different. So we did latitude correction. Then we did the free air correction. So free air correction is basically it is the difference in the station height and the datum plane. So as the station is higher, so we are adding or subtraction the field. And next we did the Bogart correction. So Bogart correction is mainly the attraction between the material between the station and the datum plane. So that attraction, and then we did the terrain correction. And next is we are if we are moving in a moving ship or airplane, here we are measuring, then we are doing the headwatch correction.
Okay. So tell me why this terrain correction is always positive.
So terrain correction is always positive because that as Earth is an uneven surface, so somewhere valley and somewhere is a mountain. So if you are measuring the gravity, so in a valley region there is a mass deficit. So mass deficit will be means it will bring down the gravity due to the mass deficit. So we have to add something. And in a mountain region, there is a attraction between the mountain mass and the gravimeter. So it will be upward pulling of the gravimeter. So that's why we have to be that will lead to the decrease in gravity, and we have to add something on it. So that's why Tennant current always we are adding.
Okay. And what is the basic difference between free air correction and the Boger correction?
So basic difference is that free air we are measuring that at a station height, and we are not considering the material between the station and datum plane. So we have nothing to do with the material between. But in Boger correction, we are considering the material between the station and datum plane. It is the if density is higher or if density is lower.
Okay. And what is this isostatic correction?
Isostatic.
Yeah, isostatic correction we use.
Isostatic correction. I don't know isostatic.
Okay. Do you know that the tidal effect
Yes,
of
yes,
the
yes, yes.
yeah, on the earth, the tidal correction? Yeah.
Tidal correction, yes, yeah.
So what is the
So
shape of this tidal correction? If we plot a curve between the different times of day and the correction of tidal that we use, then which kind of shape we get?
So it will most probably curve type, sine cosine curve type. So it will
Why
sometimes it's high.
this is so?
So because that the tidal effect mainly the moon, it's depend on the moon, the attraction of the moon on the earth, and
Okay.
as the moon is moving around the earth, so it's some position it will when it will top of the position, so it will attract more, and as is gradually going to its angle change, so that force will be diminished at 90 degree, and then 180 again came. So that's why we are measuring.
Okay, Sanu, tell me three most important applications of gravity survey.
So gravity survey we are mainly using for the subsurface geology. So we are knowing we are from the mathematical calculation and the whatever we have got from the so there is observe what we are observe. So there is a difference we are interested. So that difference will give some mineral area, some so density contrast. From the density contrast, we can predict some mineral. We can, and it's also important for the groundwater because there is density change in ground because the water is, and also its implication in the plate boundary. We can from the gravity survey we can also know that the root of the mountain, and we can predict the fault zone, seismic fault area. So these
Can
are
you
mainly.
briefly explain how will you find out fault zone or this plate's boundary using this gravity survey?
So if there is a fault area, so like if there is a converging fault, or so there will be means one plate is going down and another plate is going up. So if we from the gravity survey there will be gravity anomaly in that place. So then the normal area from that anomaly you can identify the shape of the anomaly and we can predict that.
Okay, what is anomaly?
So anomaly it is the basically that what is the we are getting the theoretical and what we are observing. So difference is the anomaly.
And how many types of anomalies are there in gravity survey?
So there is a two type. One is the Boger anomaly and is the free air anomaly.
And what is
So
the main difference between them?
and the so in one I think that Bogart plate is not considered. I think it is free air. I think Bogart plate is not considered, and so it is the mainly the the difference between the observand plus we are adding the correction. So free air and the bogger and the terrain we are adding on it. So free air and the bogger, I think that their sign is opposite.
Okay. So how you will find out that what is the particular shape of a body of a different density body in the subsurface? How will you find out whether it is sphere, cylindrical, or any other
So
shape?
uh, from the anomaly card, so what we are getting in a gravity survey from the anomaly, if it is in the Gaussian shape, so from the Gaussian shape, and so we can assume that it is if uh, its thickness is the means half width bandwidth is more is less. I think it is less than the we can assume that so we can the cylinder and sphere we have both have the dome shape curve, and if there is a bandwidth is I think it is less, then we can think that it is spheroidal body inside the and it is more than it is we consider the cylindrical.
Okay, you use two terms, bandwidth and half width. What is the difference between them?
Okay. So half width, uh, I think half width or bandwidth is both are same. So half width is actually the half of the maximum peak. So if we are getting the Gaussian shape car, so half width, so what is the power is half. So from that 2 point, so difference between the 2 point. So if we taking the power half, so that curve will cross the means it will cross the original graph in 2 point. So difference between the 2 point that is the bandwidth.
Okay, and what is the relation of half width in spherical body and cylindrical body?
So it's proportional to the depth, but I actually value I forget about it. I think 0.71, I think something. So half
Okay,
with is
okay. And tell me that how the half width, let's say the Gaussian shape is there. So the Gaussian shape is wider or narrow. So how
yes,
this
sorry.
thing will affect the depth of the body?
So if the body is near to the subsurface, so I think we got the steeper curve. So curve will be narrow, and if the it is in deeper side, so the curve will be wider.
Any reason for that?
Means as the gravity acceleration is proportional to 1 by r square. So it's if we are increasing the distance, so gravity is fall rapidly.
Okay. Okay, my last question is how the energy of an earthquake is related with the frequency of an earthquake?
Energy of an earthquake is related to the frequency. So there is a relation between the good, I think Richter relation. So it is the log 10 base n equal to a minus b something.
Okay, can you simply tell me that what is the relation? It is proportional or inversely proportional to the frequency?
It is the function of the logarithm. As the intensity increases, the number of earthquake is exponentially increased.
Okay,
Means not exponentially means it logarithm 10 to the power something means that
okay, and
so between the number of frequency between the 5 and 6 it will be 10 times more than the
okay, and you use two constants A and B. What is the
yes
significance of these constants?
significant of this constant.
On which factor will they depend?
I think A is the constant value. It is I think 7 or 8. I think A has
Okay,
a Okay, I can't recall right now that.
Okay, Asudeep, continue.
Okay, thank you, Mike. Vimal?
Why periods are called primary?
Hello?
Hello.
Hello?
Why periods are called primary waves?
So P wave are they called primary wave because the P wave we are in a Richter scale or we are so it's arrive fast. So that's why it's called the primary wave.
Okay. Which waves are most destructive in an earthquake?
So most destructive is the lava wave. So because of the its horizontal motion, so it will more effect on the man-made infrastructure. So lava wave is a more destructive. Also relay wave also destructive, but lava wave is most its amplitude is higher.
Okay. What is move out? Move out.
Means normal move out that
No, simple move out. Just move out.
I can't. I'm sorry, I don't know.
Okay. What is the slope of direct wave in time travel curve? Indicate.
So it is actually straight line. So the slope is constant.
Yeah. What does it indicate? The slope.
Slope indicates that it is a constant velocity in the upper part of the layer.
Now, what is the value of the slope in direct wave curve, which is a straight line? Yes.
What is value?
Value of the slope. Yeah. What is the value?
No, I can't recall. I don't know.
Okay. Between water and oil, which has higher seismic velocity? Water and oil.
Water and oil.
Water or oil, which has a higher seismic velocity?
Oh, sorry, I don't know that.
Okay. What is the direction of Earth rotation?
So it is moving from the west to east direction.
Say. When is the Bogart correction positive?
So between the means Bogart correction, we are applying that the material between the station and the datum plane. So if
So when it is positive.
this it will be positive when there is a mass. I think that is excess mass between the station and datum plane. So that's what Bogart.
Okay. What is the? Do you remember the difference in gravity value between equator and pole? The value difference.
So its value difference is 5.3 gal per means actually 5,300 milligal. So there is difference between the gravity.
Okay. Okay, that's all from my side. Okay.
Thank you, Vimal. Agya?
Okay, Sanu. What do you mean by gravity reduction?
Gravity reduction.
Yes.
I forget about it. I forgot. Sorry, I don't know.
Okay, okay. Tell me about the free air correction. Why do we need it?
So free air correction, if the means we are measuring that in a mean sea level, from the mean sea level we are measuring that in a height. So that's why. So we are losing gravity means due to the station height. So the gravity is proportional to 1 by r square. So as your height is increasing, so that's why the gravity will reduce. And that's why we need to be add gravity. And if the station is below the gravity, then we have to subtract it. So if station is below the reference frame.
Okay, okay. Gravity increases from equator to pole. So why does the gravity increase towards pole? What is the reason?
But actually, there is a two effect. One is the centrifugal effect, and another is the earth means equatorial bulging. So equatorial region have extra mass, and extra means radius also extra. So that's why we are the as we are moving from equator to pole, so gravity is increasing. So,
So
so
if equator has extra mass, so that will have an increasing effect of gravity, as gravity is proportional to the.
its radius is more in equatorial region. Radius is more.
Okay, okay. And what is the centrifugal effect?
Centrifugal means it will the so as Earth is rotating about its axis, so due to centrifugal effect, so this motion is always out to the radius. So that should effect lead to decrease in gravity. So but in a polar region, so there is a means Earth's rotation is so if we are calculate the centripetal acceleration, so it will be almost zero. It is zero at the pole region, and equatorial region it is maximum.
Yeah. Okay, okay. What is normal move out?
So normal move out, it is the stacking process. So from it will increase the signal to noise ratio. So actually we are doing that when there is a reflection survey. So as we are if we are adding the signal, so at first we are it being to the zero offset, and then the adding the signal. So it will improve the signal to noise ratio.
It is actually stacking what you said. I want to know the normal move out actually. What is the definition of normal move out? How do we calculate it?
So in a reflection survey, if we are plotting that the time and the distance, so distance of the geophone, so it will I think it is the ellipse type car. So
Yeah.
we are moving out. It's bring to a straight line. So we are it's in a zero offset. We are doing that zero offset means.
Okay. Okay, that's it from my side.
Okay, thank you, Arya. Okay, Sanu. My first question is, what is the shape of Earth?
So Earth shape is so actually it is the geoid shape. Means it is this spherical spheroid type.
Okay, it is a sphere type. Okay, so is there any difference between sphere or geoid?
Yes, there is difference.
And
So
what is that?
so geoid actually that means it is the true nature of the Earth. So and so geoid means we are actually whatever the getting the geopotential surface and the constant potential on the Earth, and this spheroid I think that we are getting in mathematical.
have you heard about the polar flattening term?
Yes, polar flattening.
And what is it?
So polar flattening, it is the means equatorial region is as the equatorial region, the radius is greater than the polar region. So that's why the equatorial region, the polar region is more flat than the equatorial region.
And why? Why is
So
polar
due,
region more flat compared to equatorial region?
so due to the centrifugal effect, so Earth rotation and its centrifugal effect. So at the equatorial region, there is a maximum centrifugal force. So it's will tendency to outward moving material, and that's why the equatorial region is more, it is bulging, and the in polar region is flattening.
Okay. So, and what is the value of polar flattening in the case of Earth?
I forget about it.
Okay. Mm. Okay, what is the difference between the flattening and the eccentricity? So, do you know the eccentricity in terms of ellipse?
Ellipse, yes, yes, yes.
So, what is the
So it is,
difference between the eccentricity and the flattening?
so flattening, we are measuring that the difference in radius and divide by the and eccentricity. It is the means it's measure that how much curve means in a surface. So it's actually, if you're in a mathematical formula, so eccentricity will be 1 minus, so 1 plus minus, maybe it is different for ellipse and hyperbola or all other the geometrical configuration. So it will be, it is b square by a square. B means here that minor axis and a is the major axis. And but polar flattening, we are measuring the difference. So polar flattening will be b minus a by a. But
Okay, so what is the value of flattening in the case of circle? If it is circle, then what will be the value?
so circle it will
For,
be 0.
okay, okay, good. Suppose you have a sphere, solid sphere.
Yes.
So will the value of the acceleration, gravitational acceleration will be same on the every point on this surface or different?
Please repeat. Hello, Asu, please repeat.
Suppose you have a solid sphere
Okay.
and you have to find out the gravitational acceleration on the surface.
Yes.
What will be the formula for this?
So formula gravitational acceleration is the gm by r square, where the g is the gravitational constant, m is the mass, and the r square is the distance, means what is the radius of the sphere.
Okay, will it be same everywhere or different?
So as the radius is constant, so gravitational acceleration. So you are asking the gravitational acceleration or potential?
Gravitational acceleration.
Okay, so gravitational acceleration will be same for a particular radius.
Okay,
There is a fixed
now
radius.
just convert this solid sphere into the solid ellipsoid. Now, what will be acceleration will be same or different?
No, it
It
will
will
be
be
different.
maximum and minimum.
So it will be so as means as gravity proportional to 1 by r square. So is if the distance is smaller, so that point will be the maximum gravity. So if we are measuring that in ellipse, so semi major axis and semi minor axis, so it will be greater in the semi major axis, and minor and semi minor axis will be the, I mean gravity will be means greater than the semi major axis.
Okay, now compare the solid ellipsoid with the Earth.
Yes.
Okay. So you are saying the G will be minimum at the equator or pole.
G will be minimum at the equator.
And what is the reason behind it?
Means if we are considering as a ellipsoid, so the radius will be greater in the equatorial region. So it is further away from the center.
Okay, now suppose this solid ellipsoid is also rotating about the axis which is passing through the minor axis. Okay,
Yes,
in
yes,
the
yes,
similar
yes,
in the case of the Earth.
yes,
So
yes.
will there any additional extra force act
Yes,
on
yes.
the?
In equatorial region will extra will another means due to centrifugal effect is gravitational acceleration is further reduced.
Okay. Okay. My next question is, Sanu, why do we need geophysical methods?
Because to know the subsurface for the mineral exploration, for the to know the internal structure of Earth.
Okay, can you classify methods?
Means we are doing that the gravity survey. We are doing the seismic, electrical,
Okay,
electromagnetic.
can you classify and based on this? Have you heard about active and passive methods?
Yes, 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 yes.
Okay, what are the active and passive methods?
So in active method, we are using the natural source. We are using the artificial source. In passive method, we are using natural source. So we are not putting any external source here in passive one.
So examples for passive and active methods.
So active method, it is like gravity survey and the magnetic survey also. And the passive method, sorry, passive method is the gravity and magnetic. And active method, we are like electrical, electromagnetic, where we are using
So
the external signal.
under which category you will put seismic method?
Seismic method, it is the active one. And if we are using the that is active also passive also means if we are using the earthquake, so this is only passive, and if we are using the artificial source, so that is the active
And
artificial.
what is the advantage of the active methods?
So that is the advantage that means we can select the particular frequency range. We are changing the amplitude. So we can modify the signal as our choice. So that is the
Okay,
advantage of the active.
thank you, Sanu. Thank you.
Okay, thank you.
Okay, for feedback,
Okay.
Pawan.
हाँ ये सनु सनु मेरा पहला क्वेश्चन था कि क्रिटिकल सुपर क्रिटिकल और क्रिटिकल रिफ्लेक्शन क्या है? क्रिटिकल रिफ्लेक्शन जो
Yes,
पहले
yes.
रिफ्लेक्शन होता है उसको बोलते हैं सब क्रिटिकल, और क्रिटिकल रिफ्लेक्शन के जो बाद में रिफ्लेक्शन होता है उसको बोलते हैं सुपर क्रिटिकल. ओके. और सेकंड क्वेश्चन, डेंसिटी रेंज फॉर ग्रेनाइट मटेरियल तो 2.5 से 2.8 ग्राम पर सेंटीमीटर. And third question is that why we are use gravity acceleration in gravity method, why we are not the measure gravitational force. So I also not know about what the actual answer, but the thing is that gravity acceleration with change with the time. The change of the velocity in the presence of gravitational force, so we can measure gravity acceleration. But gravity force does not change with the time. I think that's why we measure gravity acceleration. I'm not sure. And fourth question is that can you divide category of earthquake which depend on the region where it occur, like a volcanic earthquake, tectonic earthquake. I think this type of we can divide the earthquake. Or your communication also good and confidence level also good. I think it's super.
Okay, thank you.
अर्पिता?
मानो आपने आंसर सही दिए थे, बट आप थोड़ा सा कंसाइज हो सकते हो। जैसे मैंने आपसे रेंजेस वगैरह पूछी थी, तो आप उसमें आप एक बार प्लीज चेक कर लेना कि वो आपको याद रहे। वैसे इट वाज गुड।
Okay,
ओके,
thank you.
गौरी? गौरी?
Well, his answer was almost right. And one of my question was about the stable and unstable. And we are using unstable gravimeter for getting more accuracy or sensitivity. Um, uh, and for stable length spring, we are using it to improve the range of measurement, increase the range of measurement. Otherwise, his answering was nice. Okay.
ओके, आज्ञा?
Yeah, so I asked about gravity reduction. It is nothing but correcting the measured gravity value to the theoretical ellipsoid reference ellipsoid level, and the normal move out definition that I wanted was the difference in travel time at a particular offset between the travel time at zero offset. That is the normal move out. Overall, it was very good, and your confidence level was good.
Okay, thank you.
ओके, मोहित?
यस सानू, आपका इंटरव्यू अच्छा था ओवरऑल। कुछ चीजों में आप इम्प्रूवमेंट कर सकते हो, राइट? जैसे कि एक तो जो भी आप बोल रहे हो उसको थोड़ा सा और प्रिसाइजली कर सकते हो, ठीक है? जो वर्ड्स आप बोल रहे हो उनको प्रिसाइज कर सकते हो। उसको करने का एक तरीका ये है कि आप मिरर के सामने बैठ के और जो भी इम्पोर्टेंट क्वेश्चंस है उनको बोलने की कोशिश करो, और अपने आप को खुद एनालाइज करो मिरर के सामने बैठ के कि आप कैसा बोल रहे हो ना, बीच बीच में कहीं पे हेजिटेशन आ रहा है या नहीं आ रहा। तो एक चीज आप ये करेक्ट कर सकते हो। उसके अलावा आपने अच्छा दिया इंटरव्यू। कुछ कुछ चीजें जो एनर्जी और फ्रीक्वेंसी का रिलेशन है वो थोड़ा सा देख लेना, और जो शेप्स के ऊपर जो था स्फेरिकल सिलेंड्रिकल, राइट, तो उनको आप थोड़ा
Yes,
सा
sir.
देख लेना। बाकी ओवरऑल अच्छा था इंटरव्यू। ओके,
Okay, thank you.
ओके, विमल?
ये मैंने पूछा था व्हाट इज मूव आउट। मूव आउट इज द टाइम ट्रेवल डिफरेंस बिटवीन एनी टू पॉइंट्स ऑन द लोकेशन, ठीक है? स्लोप के बारे में पूछा था तो 1 बाय वेलोसिटी, रेसिप्रोकल ऑफ वेलोसिटी होता है वैल्यू स्लोप का डायरेक्ट वेव में।
Actually, you were asking that the velocity means I thought the numerical value you were asking.
हाँ, तो न्यूमेरिकल वैल्यू में पूछ रहा था व्हाट डज इट इंडिकेट फॉर रेसिप्रोकल ऑफ वेलोसिटी।
Okay.
ठीक। और मैंने पूछा था वाटर और ऑयल में किस विच हैज हायर seismic velocity, इसमें वाटर होगा क्योंकि वाटर इज डेंसर देन ऑयल, ठीक है? बाकी तो
Okay.
तो सानू, एज मोहित ने भी कहा सभी ने कि ओवरऑल प्रेजेंटेशन आपकी अच्छी थी, बस कंसाइज प्रिसाइज होने की जरूरत है वर्डिंग्स में, एंड बाकी सब सही है कि और मेरा पहला क्वेश्चन जो था वो फ्लैटनिंग के ऊपर था। सो फ्लैटनिंग इज द मेजर ऑफ ए कंप्रेशन ऑफ सर्कल और ए स्फेयर अलोंग इट्स डायमीटर, ठीक है? सो एंड बट एसेंट्रिसिटी ये है कि कोई चीज कितनी अनसर्कुलर है। सो फॉर एग्जांपल सर्कल के केस में एसेंट्रिसिटी 0 होती है, तो बिल्कुल भी वो अनसर्कुलर नहीं है। सो इस ऐसे वो ये डिफरेंस है इसमें, और वैल्यू जो होती है इसकी 1/298 होती है, आप देख लेना, ठीक है? एंड सेकंड जो था एडवांटेज जो है एक्टिव मेथड्स की, तो हाँ, एक्टिव मेथड्स एक्चुअली हम एक्सटर्नल सोर्स यूज करते हैं, दैट इज आर्टिफिशियल सोर्सेस। सो हमें क्या है कि सैलो इन्फॉर्मेशन अच्छी मिलती है। सो अबाउट सैलो इन्फॉर्मेशन अच्छी मिलेगी विद रेजोल्यूशन अच्छा होगा उसका। और जो नेचुरल सोर्सेज जहाँ यूज हो रहे हैं लाइक ग्रेविटी मेथड या मैग्नेटिक मेथड, सो इन्फॉर्मेशन विल बी डीप इंफॉर्मेशन बट रेजोल्यूशन वही मिक्स इंफॉर्मेशन मिलेगी बहुत ज्यादा। बाकी ठीक है, आपका अच्छा है, थैंक यू।
Okay, thank you everyone giving me feedback.
तो नेक्स्ट गौरी आप देना चाहोगे?
Yes, yes.
Okay, okay. So Pawan, you start from your side.
Hello, Gauri. What is the value of gravitational constant with unit?
What is the value of gravitational constant? Wait,
With unit. With unit.
sorry, with unit. Okay.
Yes. Yes.
Actually, at the surface of the Earth, acceleration due to gravity value is maximum of 9.8 meter per second square, and it varies from pole to equator.
Do you know about the geode undulation?
Yes, geode undulation is the variation of the value of geode value with the reference ellipsoid.
And in which condition we can say that positive undulation and negative undulation? Do you know about the?
Yes, yes. If there is a mass above the reference ellipsoid, it will cause an upward gravitational attraction. This causes a positive undulation, and in case of an oceanic region also, or valley region where there is a lack of mass, it will have a negative undulation.
गौरी आपकी आवाज क्लियर नहीं आ रही है।
Yes, yes.
हाँ, there is break हो रही है।
Or is it speed?
Connect होकर disconnect करना होगा।
Okay, okay, Gauri,
Hello?
tell me which type of rope? Yeah. Okay. Yeah. Gauri, tell me which type of rope property is affect the seismic velocity? I think some network issue from Gauri side.
Am I audible?
Yes, Gauri. Yes.
Oh, okay. The seismic velocity depend on bulk modulus, shear modulus, and density of the rock.
Do you know relation between the Poisson ratio and speed of P and S wave?
Yes, the ratio of velocities of E and S waves Vp by Vs is equal to 2 into 1 minus sigma by 1 plus sigma divided by 1 minus 2 sigma or so. I don't know it accurately. Sorry.
Okay, and what is the importance of this formula?
If we know the Poisson ratio, we will be able to if we know the velocity of any of the wave and the Poisson ratio, we'll be able to calculate the velocity of S waves or P wave, and thereby we can understand the lithology of the rock.
Okay.
Whether it is porous or not.
Okay. What is the velocity range of S wave in petroleum?
Sorry, I don't know.
You don't know. Okay. What is the elastic wave?
Elastic wave. It is. It's. Sorry, I cannot explain elastic wave. It's Sorry.
Okay. What is the difference between the direct wave and head wave?
Okay. In a refraction seismology, when seismic wave starts from its source, it moves through directly towards the detector, and this wave that passes directly through the surface is known as direct wave, and which the wave which is being traveled after critical refraction through the subsurface is known as head wave.
In which condition we obtain the head wave? You know about that?
Okay, when the seismic wave interfere with the surface at a critical angle, it will undergo 90-degree refraction, and this wave is known as head wave.
Okay. If a velocity decrease with the depth, then you obtain the head wave or not?
If velocity decreases, it will not give us head wave, because the wave will be deflected towards the normal.
And if we velocity increase?
Yeah.
Okay.
Uh,
Okay. I'm done.
Okay, Sanu.
Okay, anybody ask? I will ask a little bit later.
Okay, Arpita.
Gauri, what is Hooke's law?
Hooke's law is explained in case of a elastic body. Within an elastic limit, stress is proportional to strain, and this relation is known as Hooke's law.
Okay. Can you there is a constant called K in a Hooke's law when we write is F equals to Kx. What is the significance of K?
K is the elastic constant. It is a property of the material which is undergoing the stress.
Okay. What is Huygens principle?
Huygens principle states that every point of a wave will act as a source of secondary wave, and the direction of the direction tangent to the secondary waves will indicate the direction of wavefront. Next wave.
Okay. What happens to a wave as it propagates through the medium?
What happens means what happens to the particle in the medium?
Yeah, on yeah, basically क्या reasons होंगे जब वो एक मीडियम से दूसरे मीडियम में वेव ट्रैवल करेगी, तो क्या क्या चीजों पर फर्क पड़ेगा?
Okay, it can vary the volume. That means it can undergo compression and rarefaction, and in that way it can travel. Otherwise, it can undergo shear motion.
Okay. One last question. If a P wave is incident on a boundary, how it is partitioned?
P wave can be reflected or refracted, or it can be converted to S waves.
Okay, thank you. I'm done.
Mohit.
Yeah.
Yeah, Gori, tell me what is the basic difference between reflection seismology and refraction seismology?
Okay, in reflection seismology, we are utilizing the reflected waves that's coming within the critical reflection distance, and in refraction seismology, we are using the waves that are arriving beyond the critical distance, and it is and in it the waves are undergoing refractions at a
What is this critical distance?
it is the distance at which the critically reflected wave reaches the surface.
Okay. What are the basic principles we use in reflection seismology?
Basic principles.
Yeah. What are the physical principles?
Did you mean Snell's law or
Yeah, Snell's
like
law we use for the refraction seismology, and for the reflection seismology.
reflection seismology too obeys Snell's law?
Okay, and what is Snell's law?
Snell's law is the relation between the angle of incidence and the velocity ratio.
What is this relation?
What is its?
Yeah, what is this formula?
Okay. For the case of refraction, we if the wave is incident at the interface with an angle I and refracted at an angle R, we can say sin I by sin R is equal to VR VI by VR.
Okay.
Or we can say that sin I by V is equal to a constant called a ray parameter.
Okay. So can you tell me there are two formulas or two principles? One is Huygens principle and another one is Fermat principle, right?
Yes.
So what is the difference between them?
Huygens principle considers the wave nature, whereas in Fermat principle we use a ray theory.
Ray, okay. And any other difference?
Both these difference, I don't know, both these law can be used to explain the reflection and refraction.
Okay, with both these laws, we can explain this reflection or refraction. What is Fermat principle?
Fermat principle states that for a wave to travel between 2 points, it will choose the path which have the minimum travel time.
Okay, minimum travel time. Okay, and what is this? What is the path it will choose for the minimum time? Whether it will be like straight line or something else, curved line.
Of course, it will be straight line, but can have deflections due to the change in medium.
Okay, okay. So have you heard the term dynamic correction and static correction?
Yes.
Yeah, tell me.
Static. These are the two corrections that is being applied to seismic reflection survey. And in static correction, what we are doing is to reduce the correction that is being occurring due to the difference in elevation. And whereas in dynamic correction, we are utilizing it to correct the normal move out value.
Okay. And do you know about this signal by noise ratio? What does it mean?
It indicates the quality of the wave that we are detecting, but how much amount of noise it is contained in the wave that we are detecting.
Okay. And for good signal, what should be the signal by noise ratio? It should be 0 or it should be infinite.
For a good wave, it should be greater.
Okay. And can S wave propagate in liquid?
No, S wave cannot travel in liquid.
Then what will be the velocity of S wave in the water?
Its velocity of S wave is represented by root of mu by rho, where mu is the shear modulus. Yeah.
Okay. So what will be the velocity in water of S wave?
Sorry, I don't know. It's S wave will be in water. It will be 0.
For oil
Oil 2.
and for petrol?
Yeah, liquids generally have S is equal to 0.
Okay. And do you know that deconvolution and why we use this in seismic survey?
Sorry, I don't know about usage of deconvolution in seismic
What is
survey.
Poisson ratio?
What is?
Poisson ratio.
It is the ratio of the lateral strain to longitudinal strain.
Okay. And what is its theoretical values possible?
It can extend from 0 to 0.5, and for a compact solid, it will be equal to 0.25, or it is then the material is known as Poisson material.
Can it be negative?
And I think it's no.
Okay. And can you tell me what are the different methods of measuring the magnitude of an earthquake?
Magnitude can be measured based on the amplitude of S waves, and it can be measured based on the amplitude of body waves. And there are surface wave magnitude and body wave magnitude and moment magnitude.
And which one is most useful?
A moment magnitude method is used in the case when there is a heavy earthquake, and the magnitude is so high.
And why this moment, this body wave magnitude and surface wave magnitude can't be used for high magnitude earthquake?
Because both these values will saturate at higher values of earthquake magnitudes.
Why this happens?
It's I don't know. So I
Okay, what
don't know.
tsunami?
What is
What is tsunami?
tsunami? It is a consequence of an earthquake, which generate heavily moving waves within the oceans.
Okay, you said that tsunami is a consequence of earthquake. What are the other possible consequences of an earthquake?
Volcanic eruptions can be resulted from earthquake.
Okay, how will you find out a velocity of a tsunami? Is there any formula? Do you remember?
Sorry, I can't recall.
Okay, what is the relation between P wave velocity, S wave velocity, and the Poisson ratio?
It's equal to Vp by Vs is equal to 2 into 1 plus sigma by 1 minus 2 sigma.
Is it correct or you are just guessing?
It's according, it's from my remembrance. I don't know whether it is. I'm not sure.
Okay, look at this formula again after interview. Okay, So, can you tell me about the horizontal resolution and vertical resolution we use in seismic survey?
Yes, yes. Vertical resolution, both this type of resolution will decrease with depth. That's the knowledge I know.
Any formula do you remember?
Yeah, for vertical resolution, the depth of resolution will be of the range lambda by 4, and for horizontal resolution, it will be it is proportional to root of wavelength.
Okay. And can you tell me why this factor of 1 by 4 is there?
Sorry, I can't. I
Okay,
don't
okay.
recall.
What are the other possible names of P wave?
P wave is the primary wave, or it is also known as compressional waves. That's all.
In which wave there will be a volumetric change? In body wave or S wave? P wave or S wave?
In S wave, in P wave, it creates volumetric change that is resulting in the compression and rarefaction.
Okay. And curl of a P wave will be 0 or non-zero?
Curl of
Yeah, if you are taking curl of the P wave velocity, P wave motion, so it will be 0 or non-zero. Okay, first of all, tell me what is this curl? What this curl signifies?
It's the rotating effect. It indicates the rotating effect.
Okay, so P wave is rotating or irrotating?
It is not rotational.
Okay, then curl of this motion will be?
Zero.
And in case of S wave?
It will not be zero. The shear.
And which waves are dispersive in nature?
Body waves are not dispersive. Surface waves are dispersive.
Okay, and what is my last question? What is this crossover distance?
Crossover distance is the it is a distance that is indicated in refraction seismology. It indicates the distance at which a refracted ray will be detected primarily than a direct wave.
And on which factor this crossover distance will depend?
Crossover distance. I don't remember. I think velocity.
Okay, velocity is one factor. Another one?
Sorry, I don't know.
Okay, thank you, Ravi.
Okay,
Yes.
thank you, Mohit. Sanu?
Okay. Okay, I'll ask. Okay, Gauri, can you differentiate between the critical distance and crossover distance?
Critical distance is the distance at which critical reflected ray is reaching, and crossover distance is the distance where refracted ray is primarily detected over the reflected direct ray.
Any significance of the both critical and crossover distance?
The critical distance is used as a indication of from which range we are measuring in reflection survey, and for which range of distance we are measuring for refraction survey. The signal crossover distance. I don't know. I don't know about the significance.
Okay. Means if you have the two layer, so upper layer is velocity is v1 and second layer is the v2. So
Yeah.
if the lower layer is the lower velocity than upper layer, so can you get the critical angle?
The deeper layer have lower velocity. That's what you
Lower
meant.
velocity. Yes.
Then can we get critical angle? Actually, I think we can. In case of in optical fiber case, when waves is moving from denser to rarer medium, then the refraction, total reflection is happening. So I think it is possible. However, sorry, I can't confirm.
Okay, you know that acoustic impedance.
Yeah, acoustic impedance. It is the it decides how much amount of wave is being reflected and refracted when a wave incident on an interface.
And it's dependent on which factor?
It depends on density and frequency, I think.
Okay. Okay, next is the as we know that the Earth internal structure of the Earth, then which means core, crust, or mantle, so which has the maximum density?
Density increases towards the center of the Earth, so inner core have maximum density.
So can you put the value? What is the maximum value?
It's about 13,000, 12 to 13,000 kilogram.
Okay. What is the elastic rebound theory?
Elastic rebound theory explains the process of occurrence of earthquake. It states that earthquake will occur when the strain within the rock exceeds its breaking point, and it will release energy in the form of elastic waves with a seismic velocity of the range several kilometers per second.
Okay. And what is the isostasy?
Isostasy is the it can be stated as the compensation of a topographic load by a less dense subsurface area. Or it okay.
Can you name some model which explains the isostasy?
Yeah, isostasy is mainly explained by two models, Airy and Pratt model. In Airy model, we use the concept of that the density of a crust mantle layers are constant, whereas in Pratt model, we are assuming we have variation in the density at different columns of the crust according to the height of the top of height above the mean sea level.
Okay. Okay, there is another model. Do you name?
It's Benning model, but I cannot explain it at this point.
Okay. Okay, my next question is, do you know about the tidal effect? So what is the reason for the tidal effect? Tides we are getting.
Oh, okay. It is. It indicates it is due to the motion of the sun and moon, other planets on Earth.
Means what you know that the spring tide and neap tide. So what will be the position when we are getting spring tide and when we are using neap tide?
Sorry, I don't know.
Okay. Okay, that's from my side. Okay. Anyone ask now?
Vimal?
Okay. Do you know three types of rocks?
3 types of
Rocks. 3 types of rocks.
mainly we can divide it as sedimentary rock, metamorphic rock, and igneous rock.
Yes. Yes. So, which of these 3 rocks have highest seismic velocity?
Seismic velocity will be higher in case of metamorphic rocks.
Yes. What do you mean by fault plane solutions? What
I
do
didn't
they
get
indicate?
it.
Fault plane solutions. What do they indicate?
Okay, fault plane solutions gives us the focal mechanism that's happening around the focus of the earthquake.
Okay. Can you name me 3 types of faults?
Faults are mainly divided into 2, dip slip and strike slip fault. And again, a dip slip fault is divided as normal and reverse fault.
Okay. Which type of fault is found in Himalayan mountains?
Sorry, I don't know.
Okay. What do you mean by multiples?
Multiple?
Multiples.
I don't know. Sorry.
Okay. Okay. What is the difference between P waves and S waves?
P wave is moves longitudinally, and S waves moves in transverse nature. P wave can move through solid and liquid. S waves cannot move through liquids. That's the main difference.
What is the difference between Pitavo's correction and Coriolis? No, Pitavo's acceleration and Coriolis acceleration.
Ito's acceleration indicates the contribution of the velocity of the instrument to the centrifugal force, and thereby it affects the value of gravity. And centrifugal force, it have a deflecting effect on the moving body.
If a body is moving in the eastward direction, what will be the direction of the Pitavo's acceleration?
It will cause an increase in the centrifugal force, and there it will have an increasing effect of centrifugal force, so it is acting outwards.
Okay. What is the direction of Coriolis force in northern hemisphere? Right or left?
In northern hemisphere, Coriolis force act towards the right of its motion.
Okay, that's all from my side.
So Mana, Would you like to ask some question from Gauri?
Yes. Yes. May I?
Yes, of course.
Yes, yes.
Sometimes ago, Mohit has told about static and dynamic correction. Can you please tell me why these corrections are called static and the other is called dynamic?
In static case, it will not change with the velocity, and whereas dynamic case, the correction varies with velocity. I think that may be the reason.
Not exactly. Okay. Now tell me another thing that what type of deconvolution the name what type of deconvolutions you know?
Sorry, I don't know about it. I cannot explain.
Okay, no issue. Which methods are most favorable for groundwater exploration?
Refractions out of the refraction and reflection seismology. That's what is.
Out of listen, mainly to which main methods are used in groundwater exploration?
Mainly we use electrical methods. Other than that, we can use seismic methods.
You are missing a major method.
Sumana, one thing
Yes.
I want to inform you that we are only asking from the gravity and seismic methods.
Oh, I'm so sorry. I don't.
Okay, okay, no problem, no issue. That's so I think you should know. That's why I
Okay. Oh,
told you.
actually, I
Okay,
don't know. That's why I
okay,
was
okay,
asking
okay,
from resistivity and IT. Sorry.
okay. We are just asking from in the upcoming session. We will also merge upcoming methods.
Okay.
Okay,
Sorry. Okay.
okay, no issue.
So can you please tell me the types of noise in seismic section present in seismic section?
There is coherent noise and non-coherent noises.
Can you give some examples of coherent noise and incoherent noise?
Sorry, I cannot recall.
Okay. Now tell me, in case of marine, what type of source we can use?
Actually, in marine survey, we will use. We are using air guns, water gun, spark.
Okay, and in case of ground survey, which let me tell you ask you one thing. In case of ground survey, what type of source would you prefer, dynamite or vibrosis, and why?
I prefer vibrosis because it is more of a concentrated, repeatable energy source than dynamite.
And the main use of vibrosis is because it's a controlled source and dynamite is an uncontrolled source. Okay.
Yeah.
Okay. Can you please tell me the use of uphold survey in seismic? Why should we use uphold survey?
You mean upward continuation, right?
No. I am not meaning about I am not telling about upward continuation. It's used in gravity or magnetic. I am asking about uphold survey, which is used in seismic.
Upward survey.
Upward meaning uphold. UPHOLE. Uphold.
Hold.
Yes.
Sorry, I don't know about it.
Or from gravity. Can you please tell me what type of corrections are used in gravity survey? On gravity data, actually, sorry.
What types of
Corrections.
Corrections. Okay.
Yes.
There are mainly more than 5 corrections. There are latitude correction, free air correction, Boger correction, terrain correction, drift correction, ethos correction. That's all I remember.
Why should we use latitude correction?
It's due to the variation with the latitude. That is when we are moving while measuring. That's when we are using it, I think.
Okay, and what type of variation in gravity with latitude we can observe?
It will have a effect, variation directly proportional to sine of 2 lambda, where lambda is the latitude angle, and it is
No,
maximum
no,
at
no, no. What type of variation you will see in latitude? You are telling about 0.811 sine of 2 lambda. That's fine. That is latitude correction. But I am asking about the variation with
of
latitude.
gravity value. Okay, okay.
Yes.
In acceleration due to gravity is maximum at the poles and it is minimum at the equator.
Okay. Now tell me another thing that in case of Booger correction, if we are at mean sea level, then is there any use of applying Booger correction?
No, we don't need to.
Okay, that's fine. Now tell me another thing that in which type of exploration we will use smaller spacing, mineral exploration or oil exploration, gravity for gravity.
Exploration or
Oil exploration, in which type of in gravity survey, in which case we need smaller spacings, mineral or mineral or oil.
Oil exploration.
Yes, that's good. Why?
So that we cannot miss out the smaller anomalies within the broad.
Actually, the basic thing is the anomalous body in case of oil exploration is smaller than it for minerals. That's why we have to use smaller spacing in oil exploration. Now, so okay, that's okay from my side.
Okay, thank you, Sona. Okay, Gauri, tell me, why do we study earthquakes?
Earthquake is being studied to understand the internal structure of Earth mainly.
Just only for the internal structure of the earth.
Yeah, it's mostly done for it.
Okay, and what is
And
how
to
we
understand the velocity distributions within it.
okay, how will you define an earthquake?
An earthquake is the sudden is due to the movement of the surface, vibration of the surface, which is resulted from the gigantic energy that is released at a subsurface area.
Okay, and what is the order of that energy? Just order in 10 to the power something in the joule or on something. Okay.
Sorry.
So how can we measure earthquake size?
Earthquake size can be measured using it can be measured using intensity or magnitude scale. This is what you meant?
Yes, yes.
Okay.
So in the intensity scale, what actually we are measuring what quantities? What any physical quantity we are measuring in intensity scale?
In intensity, We are measuring the sort of destruction or calamities happened in the area. It will be based.
Okay, good. So intensity basically depends on which factors?
Intensity can depend on the depth of the earthquake and the nature of the even the nature of the soil in the area and the construction codes that is used in the area and the civilization that being happened in the area. These all can depend intensity.
Okay, good. Let now come to the magnitude scale. So which physical property we are measuring here?
Actually, we are basically measuring the amplitude. Rather than that, we also have the dependence of epicenter distance and all that.
So
And those are
is amplitude a physical property?
no.
I have asked about the physical property in the magnitude scale.
Okay.
Okay, so it is the energy. Energy is a physical property. So there is
Okay.
any relation between the energy and the magnitude scale?
Yes, energy is magnitude is related to logarithm of energy.
Okay. Suppose at the 8 a.m. at the 8 a.m. you are is earthquake of magnitude 5, and
Yeah.
after 1 hour at the same place you experience the earthquake of the 7 magnitude. So now just tell me the what will be the intensity and energy in the both cases as compared to the previous one. By what factor intensity will increase or density will increase? Sorry, energy and intensity.
Okay. Energy varies with a range of 1,000 joules or joules, I think. Kilojoules. Oh, I don't know the unit.
What is the
And
unit of energy?
I know it's joule, but I don't know the
Okay.
magnitude.
Just I am saying for the comparison
Okay.
between the
It will
earthquake of a
vary with.
magnitude 5 and 7.
It will have a ratio of 1,000. That is 7 magnitude earthquake will have 1,000 times the energy.
Okay, good. And in terms of intensity?
Intensity is related to magnitude almost linearly, but I cannot recall the
Okay,
formula.
it is the okay, good. It is the linear relation.
Yeah.
Okay. Okay. Can we predict earthquake?
We can almost predict the location of the earth, but we cannot predict the time of earthquake.
So how exactly you can predict the location?
We can no, it is not possible in every case, but when there is frequent areas where there is frequent occurrence of earthquake, when there is an absence within a time period, we can guess that the strain is accumulating and there is chance for earthquake.
Have you heard about seismic gap theory?
Yeah.
So what is it?
Sorry, I cannot explain it.
Okay, no problem. Um, okay, can we predict intensity?
Can we predict intensity?
Intensity of an earthquake?
No.
Okay, so what is the seismic microzonation?
It is the division of an area, the smaller areas, to analyze the amount of hazard or damage an earthquake can cause. it depends upon several factors like um, the civilization and the engineering factors, soil type,
Okay.
etc.
So, can you tell us about the seismic zonation of India? How it is divided based on the seismic zones?
India has been divided into mainly 4 types based on the intensity of earthquake that can occur in an area. They are named as zone 2, 3, 4, and 5. And fifth zone is the most in area where most intense earthquake occur. And zone 2 is the least intense earthquake occurring
So,
area.
your district in which zone?
I belong to zone 3.
So, it is okay. Good. Okay. What is elasticity?
Elasticity is the property of material which states that within an elastic limit, the stress is proportional to strain.
So, can you divide material based on elasticity?
We can divide it according to the range, like whether it is some tensile material or it is a brittle material, like that.
Have you heard about the plastic materials?
Yeah, plastic material. When elastic limit is crossed, and further we apply the force, the material will turn to plastic nature. That it will return to its original dimension.
Okay, give us examples of elastic material and plastic material.
Almost every material is elastic. It will return to its original dimension within the elastic limit.
Okay, what is the proportionality limit?
What is proportionality limit? It is the amount of stress that the material can sustain so that it can maintain the elastic nature.
Okay, so what is the stress?
Stress is the restoring force that is acted upon a body when we apply force externally.
Okay, so is it a vector quantity or a scalar quantity?
It is a tensor quantity.
What are the tensors?
Tensors are material are the forces which depend upon the direction and it is defined within the plane in which it is being acted.
Okay, good. Okay, so okay, can you arrange the rocks and minerals according to the density? Arrange the classification.
Sorry, I don't know.
Okay, which is the highest mineral which has the highest mineral which has the highest density?
Sorry, I don't know.
Okay, so can we measure density?
Yes, we can measure density.
How?
We can measure it. I don't recall the methods.
Okay. So what is the so why do we need gravity correction?
Actually, we are measuring the density contrast in gravity method. Okay. What was the next question? I didn't hear it.
What is the why do we need gravity correction?
Okay, gravity correction. Actually, our aim of a gravity survey is to detect the anomaly within the subsurface. In order to identify that, we need to correct the measured gravity for the anomalies that can or the correction that can be resulted from other reasons.
Okay.
To analyze it with the theoretical value at the reference.
And what is gravity anomaly?
Gravity anomaly is the difference between the corrected gravity and the theoretical value at the reference ellipse.
And what is the reason behind it?
Anomaly. It is due to isostatic correction. That is the variation the density at the subsurface with a topographic load.
Okay. And what are the residual gravity anomaly and the regional gravity anomaly?
Okay, gravity anomaly we calculated will have higher wavelength component and lower wavelength component, and the higher wavelength component, which is due to the deep heavy masses, is regional anomaly, and we need to reduce it from the Vogel anomaly to analyze the shallow anomalies which are of the interest in gravity survey.
How can we separate residual gravity anomaly from the regional gravity anomaly?
We can use different methods. Primary method is visual analysis, which can be combined with the least square method. And second method is using filtering. That is, we will convert, we will represent the gravity anomaly as Fourier series, and we will separate it using filtering. And in case when it is since the gravity anomaly variations are not periodic, we will represent it in Fourier transform form and then use convolution theories to separate it.
Okay. What is convolution?
It's an operation we do to filter out different frequencies. I think, I don't know. Sorry.
So for the commercial interest, which type of gravity anomaly is important?
Commercially, we need to find out the residual anomaly. That's why we are separating the region anomaly.
So which type of filter we will use here?
We will use high pass.
Why?
We need high frequency waves. That represents the residual anomaly.
Okay. So Gauri, my questions are over, but I have a very general question. What is suppose you are okay? What is the role of a geophysicist in GSI?
We need to use we need to apply the knowledge of different fields for the exploration, different methods.
Okay.
And,
exploration or for the exploration. And okay, so the main objective of a GSI is, what is the main objective of GSI?
Mineral exploration.
Okay, for the mineral exploration. Which type of mineral GSI will focus?
It can vary according to the.
Okay, okay. Thank you.
Okay.
Okay, you can give one by one feedback, everyone. Sanu.
Hello. Gauri, your overall is good. As you started little bit struggling, but you gradually so your confidence level is good. And whatever I question ask, that you are mostly correct. And one question I asked, what is the acoustic impedance? It depends. So acoustic impedance, it is depend on the density and velocity. It is, you said that correctly, that it is reflection and transmission coefficient we are using it. So overall good, and that's from.
Okay, Arpita.
गौरी इट वाज गुड, आपका कम्युनिकेशन और आपका कॉन्फिडेंस बहुत अच्छा था.
मोहित.
यस गौरी, आपका इंटरव्यू काफी अच्छा था. कुछ सजेशंस है 2 or 3 दैट यू कैन इम्प्रूव. द फर्स्ट थिंग इज थोड़ा सा कॉन्फिडेंस इंक्रीज करो अपना. द सेकेंड थिंग इज क्वेश्चंस का आंसर आपको पता होता है, बट हो सकता है किसी घबराहट की वजह से आप नहीं बता पा रहे हो. सो आंसर देने से पहले 2 or 3 सेकेंड्स का पॉज लो, थोड़ा सा सोच लो उसको. अगर आंसर आ रहा है तो उसका आंसर दो, अदरवाइज आप उनको डायरेक्टली सॉरी बोलो. ओके, या फिर ऐसे बोल सकते हो कि मे आई गेस. सो दीज आर द थिंग. बाकी अच्छा था इंटरव्यू.
Okay, Vimal.
I asked one question about the type of fault found in Himalayan region. It is reverse fault. Okay. And the other question was what are multiples? So multiples are noise signals which are due to multiple reflections of the seismic wave from different parts of the layers which we are not interested in. Okay, rest of the answers were right and it was very good. Okay.
Thank you, Vimal.
Okay, Pawan.
Yes. Gauri, I would ask you one question. What is the range of velocity of S wave in the petroleum? So you gave some guess. I think we know that S wave will not travel in a liquid portion. So sometimes panels also check presence of mind. So otherwise your communication and confidence level is also good, and you can defend a lot of the questions. I think overall good.
Thank you, Pawan.
Okay, Sumana.
Okay, I have something to answer that. The basic difference between static correction and dynamic correction is, in case of static correction we are applying the same velocity throughout the seismic trace, but in case of dynamic correction, say as NMO correction, we are changing the velocity for each and every trace. That's why it is known as static and dynamic. And upwell survey is used for detecting the amount of explosive in case of yes, in case of seismic survey. And Gauri, can you please tell me the other questions? I just forgot actually.
I cannot recall all the questions.
Uh,
You asked about the groundwater
Okay,
detection method.
groundwater one is basically we have to use resistivity and IP method, combination of resistivity and IP method for groundwater exploration. And seismic. There are many types of deconvolution. Basically, the main branches of deconvolution is predictive deconvolution and deterministic deconvolution. And I have asked about noises, I guess. So, coherent noise is multiples, and incoherent noise may be due to movement of streamers, traffic signals, that type of things. And um, I can't recall all of my questions. That only and
Corrections. I asked about correction.
which correction?
Different corrections. I think I answered it.
Yes, you have answered the different corrections and other some questions. In from gravity, you are very good, but I will suggest you to recall the seismic portion once again. That may be helpful for you.
Okay, thank you.
Okay, thank you.
Okay, Gauri, you have answered all the question very well, and communication is good, presentation skills also good. फ्यू सजेशन मोहित ने ही बताया कि जस्ट क्वेश्चन नहीं आ रहा तो इमीडिएटली डोंट से कि आई कांट रिमेम्बर बिकॉज इट विल लीड टू द नेगेटिव इम्पैक्ट जस्ट से कि आई एम अनेबल टू रिकॉल यू कैन से लाइक दैट और समथिंग सो बाकी सब अच्छा था एंड एवरीथिंग इज गुड बस थोड़ा टाइम लो डिनाई करना है तो और आंसर भी करना है तो
Do I need to improve, explain it furthermore, the question, or
no you are
am I
explaining
made?
well
Okay,
okay thank you
thank you, everyone.
Okay, so what's the next plan? Next session on which topic?
Asudev want to give today.
Okay, Asudeep. Yeah. Hello.
Asudev. Hello, Asudev is not responding.
Asudeep, आपकी आवाज नहीं आ रही है. Okay.
Sumana do you want to give today?
Yeah, we can
Yes,
do it today.
I can.
Okay, there can be some network issue from that side.
Okay, okay.
Mm,
start
if
from the-
you okay, yes.
Okay, Pawan, start some few questions. So actually, Sumana from geophysics background. Okay,
Yes.
so we can ask some tough question to her.
Okay, so Sumanna is from geophysics background. Okay, good.
Yes.
Okay. So अभी टीम अच्छी हो गई अपनी, है ना? ओके, तो बताइए नेक्स्ट प्लान क्या है?
ओके, पहले नेक्स्ट प्लान हमारा होगा ना जो इलेक्ट्रिकल और जो इलेक्ट्रिकल और
सॉरी
जो मैग्नेटिक है ना जो ईएम सेक्शन है नेक्स्ट वीक हम लोग वही डिस्कस करेंगे मींस पैकेज ऐसे होगा ना
you can stop the recording
अच्छा 1 मिनट सुमन वांट टू गिव द इंटरव्यू
अगर 2 लोग बचे हैं तो कल रख लेंगे क्योंकि बहुत लेट हो गया है
ओके, हाँ, ये भी कोई इशू नहीं है. अगर
थोड़ा सा जल्दी रख लें क्या अगर किसी को इशू नहीं है तो जल्दी कर लें
नो आई हैव नो इशू मेरा ही बच रहा है मोहित का बच रहा है है ना
3 लोग बच रहे हैं ना अभी मोहित आशुदीप और सुमन्ना
ओके ओके
कल 8 o'clock या 7:30 रख लो अगर नहीं है प्रॉब्लम सबको तो इफ पॉसिबल
I can suggest one thing that in the next month we can arrange some full syllabus interview within 25 to 30 minutes time limit. That should be beneficial for us because I think in case of original interview, yes,
we will do it as a gradually first we are completing
yes
statement topic by topic
I am also telling the same thing na ki in the next month after revising the topic then only we can go for the full syllabus.
okay
yes,
so
we will do it.
how was the experience Gauri and Sanu
So for me, it's good. I mean, it's helped me a lot to answer all these questions. So it's for me, it's great helpful.
And Gauri?
It helps me a lot. I understood the portions I need to cover or focus more.
Okay, good. So कल session रख लें फिर?
Yes, yes.
So is everyone okay for tomorrow's session?
Yes, yes.
If everyone is okay, we can change the timing or
Yes.
make it at 7:30
Yes.
also. Otherwise, it will be difficult to cover 3 also.
So कल कितने बजे?
7:30 क्योंकि तब फिर 10:30 तक सबका हो जाएगा.
Okay, 7:30 पे सब ready है?
Okay, okay.
Okay, okay.
ठीक है, okay. Okay, thank you everyone. See you tomorrow.
Thank you.
Good night.
Good night.
Okay, good night.
Good night.
Yeah, thank you. Good night.